Welcome you all in this new video, and today video is going to be very interesting because in this video we are going to study about the radiocarbon dating. Okay, and this technique is used to find the age of any fossil that we find in our earth. Okay, you have seen many time in the news that scientists had found a particular fossil. Okay, and then they tell in the news that yes, this is around 500 years ago, million years ago. So how all these activities are done? Okay, which kind of the scientific formula and technique is used to find the age of such fossil that we found? Okay, so it seems very complex and very tough that if we see that if we imagine in our life that we don't have that kind of advanced machines to understand the age. Okay, so which kind of formula then we will use? In this video we are going to study a formula, okay, that you already know, but you have to modify that. That's the decay law. Decay law. Okay, in your nuclear physics you studied this law. Okay, but you are rarely told in your school and college days that this law can be used to identify or used to determine the age of particular fossil and particular, you can say, any living body. Okay, any living remains you find in the earth's surface. Okay, so in this video, carbon dating, okay, what is the principle and what's that formula and expression that is used there? Okay, we will understand all this in this video. So let's start our video, and this is going to be very interesting, guys. So before I explain that what is that formula and how we can use to determine the age of a particular fossil there, so first of all understand that why we are going to use this decay law here. Okay, and it seems very illogical because when we talk about decay law, we usually thought that yeah, decay law is regarding with the uranium hydrogen mixing, okay, fusion, nuclear fusion and fission, but it is a overall concept. It's a multi-dimensional law, you can understand like this. So first of all understand from very fundamental, okay, what is going on in the nature, and when this what is that element which is there in the nature which helps us to find the age of that particular fossil. Okay, so let's understand that. You all know that our sun produce what? Cosmic rays. Okay, and these cosmic rays are interfering with our atmosphere. Okay, we know that, and in our atmosphere we know that nitrogen is present in a very abundant way. Okay, in a very abundant amount. So when that cosmic rays, okay, interact with the gases in our atmosphere, okay, with the gases, so it produce a neutron. Okay, this is, let's say this is a neutron. Okay, and that neutrons gets interacted with what? It get interacted with the nitrogen. Okay, let's understand this with an equation. Let's say this is your neutron, okay, and this is your nitrogen atom present in the atmosphere. So it provide us with the new radiocarbon, that is this. Okay, so this carbon, okay, C146. So what is happening here, guys? Please, I am talking in a very scientific way. If you are a science student, then you will easily calculate it or easily get it in your mind that what is going on here. Okay, so what is happening, guys, here? Cosmic rays create or induce a neutron, and that neutron is combined with the nitrogen atom that is present already in our atmosphere. And when that nitrogen is combining with that neutron, it creates a new radio element, or we can say isotope of the carbon, that is C146. And during the photosynthesis, okay, all the plant in this earth, okay, they all grow, or you can say they all get energy because of photosynthesis. So because of this photosynthesis process, what is happening here? This carbon is going, or you can say entering in our food chain. Okay, food chain means what? Food chain is the chain which connect with all the living elements within each other. Okay, you can easily understand like this. So when this carbon is entering through photosynthesis with this plant, and this plant, okay, and you can say not even this plant, with every kind of the living things which get energy through photosynthesis, and because of entering in the food chain, it gets also introduced in the animals, human beings, or all the living animals on the earth. So at the crux we can say that This carbon isotope that is formed because of the mixing of neutron and nitrogen, okay, this is present in every living body on this earth, okay, and this isotope help us to understand what is the age of that particular fossil, okay, when it is found after many years later, okay, when it died. Like this is a horse, let's say it takes around 500 years, okay, and after 500 years we found this fossil there. So how we can, because this, okay, what we can say, this carbon isotope is present in this fossil, which help us to find the age, okay, of that particular, that how old this fossil is. How it is found? Because of this radiocarbon, okay, which is formed there. So this is all about that, what's the element which help us to calculate the value of that, or you can say what's the time period, okay, and how old that fossil is. This is that element which help us to found that, okay. So now we will get, or we will try to explain, I will explain that formula within the two steps. You can easily calculate, okay, this is the formula, and this way you can easily identify the age of that particular fossil. So now get further. So let me explain you two things, okay. First, you have to understand the decay law, okay, and you had already heard or learned this law in your nuclear physics, and also in you can say many other branches of the nuclear physics, okay. So what's the nuclear law? It says that n is equal to n0 e lambda t. So this is the, I'm writing this law directly. I'm presuming in my mind that you already know the nuclear physics and all the laws regarding this, okay, how the nucleus disintegrate, all the things, okay. So I will explain a little bit. So what is n? N is the number of atom, okay, present in that particular substance at time t. Okay, what is the n0? N0 is the initial number of the atom which was present in that medium, okay, when it was not disintegrated, but yet it was start to be disintegrate, okay. And what's this lambda? Lambda is nothing, it's a decay constant. Decay, it's a decay constant, okay. So this is our decay law, and on the basis of this law we can easily identify the reactivity and what is the activity is. Here is another concept which helps us to understand that, okay. So what's that concept? That is activity. So this is not activity like that, this is radioactivity. So this is represented by R, okay. And what's the radioactivity? Radioactivity is nothing, this is the disintegration rate. You can say how, what's the rate of disintegration of a particular substance, okay, particular nuclear substance, okay. And I am using this law, why? Because in nuclear physics we studied that whenever two atoms combine with each other, okay, all kind of that process comes, or you can say all the process like that, okay, comes under the decay law, or you can say nuclear physics, okay. All the laws of the nuclear physics are applicable there, okay. So this is the reactivity. So what is the reactivity is R, okay, and this will be, I am writing it directly, okay, R0 e lambda t. This is the reactivity. What is the R here? R is the reactivity when we are measuring the activity of that particular fossil. Let's say this is a fossil, okay, and I found it, let's say today I found this fossil. So I will measure that what's the reactivity of this substance is, okay. Let's say today what is the radioactivity of, radioactivity means what, today with which rate it is disintegrating, okay, that is R. And this, and what is the R0? R0 is the activity when this, okay, when this fossil was fresh, means it was just start to be disintegrate, okay. At that time what was the activity of this substance? That is R0, okay. And the remaining are same. Lambda is the decay constant, and T is what? T is your time period, okay. And time period means what? This is the time period which tell this value of T, which tell us that this, yes, this is the age of that fossil, okay. So let's do it for the, okay guys. So this is your machine which is used to, okay, this is the modern machine, okay, you can say, but we are focusing only here on the how we can, on the basis of our formulas that we know, okay, with that formulas how we can calculate the age of a particular fossil. So guys, this is the case here. Let's say here is a I found a remain or fossil of a plant here today, okay, and I measured the activity or radioactivity of that fossil through a machine. I just show you that mass accelerated spectroscopy, okay. So let's say the that is R, okay, and in present date when I am measuring the activity of that substance, that is R, okay, and let's say that R0 was the activity of that substance. Activity means what? Activity means what's the rate of disintegration, okay. It was at the time when it was very fresh stream, you can say, okay. Okay, so now we have to understand one thing more. This is the half life of carbon C14. Remember C14, this is the same element which is present in every living body on this earth, which help us to understand what's the age, everything, okay. So this radioisotope half life is 5730 years, okay. It takes 5730 years to just disintegrate into its half portion, okay. So that's a different concept, but we will use the half life of this carbon here, okay. So now if I do it further, so it will become this, okay, and if I do it more further, then it will become lambda t is equal to log E R over R naught, okay. So now this is expression that we got, okay. So if we do it further, so what we got, you can say log E R over R naught, okay. So if I do, what's the T? This is the time, this is the age, okay, that we are going to find. So what will be our 1 over lambda log E, okay, R over and R0. I am not expanding this log E here, okay. So if I ask you, if you had already studied this nuclear physics and all the formulas relating with the disintegration laws, okay, so what they tell us? They tell us what's the relation between the half-life of a particular radioactive substance and decay constant. Decay constant and half-life of that particular substance, what's the relation between that? So we came to know that what's this is the law, okay. This will be 0.6931 over T1 over 2. So this is the relation between the decay constant and half-life of that particular material, okay. So by putting the decay constant value here, we can easily identify this, okay. So ultimately this is the equation that we got, and from which equation we can easily identify what is the age of a particular fossil that we found today, okay. This is the formula, guys. We just have to understand this value R0, okay, because R0 is the value of activity. Activity means what? I told you, activity is the rate of disintegration of that particular substance, and R0 is the activity at the point when that plant or when that living being was fresh, and this was calculated through the mass accelerated spectroscopy. So guys, through this formula you can easily identify what is the age of particular fossil that we found in present date, okay. So I hope you like this video, and if you like our initiative, then give a thumbs up, and let me show you at the end. This is the machine, guys, I was talking about. This is accelerator mass spectroscopy, okay. It is based on the mass. Through the basis of mass it and spectro principle also, it easily identify what is the age and what will be the reactivity, okay, very accurately it find. So this is all about carbon dating. If you like our initiative, then give a thumbs up and do subscribe our channel. Thank you so much.